Introduction. Microbiology laboratory is a place where its workers are exposed to a host of infectious and non-infectious hazards. There is an increasing awareness regarding the types of hazards and laboratory-acquired infections. Different means to prevent these infections are also being designed. Safety is now the responsibility of the worker, and providing safety the responsibility of the hospital or employer. The principle of biosafety. Laboratory biosafety is the term used to describe the containment principles, technologies, and practices that are implemented to prevent unintentional exposure to pathogens and toxins or their accidental release. This must be differentiated from biosecurity, which refers to institutional and personal security measures designed to prevent the loss, theft, misuse, diversion, or intentional release of pathogens and toxins. Risk groups. This is the classification of microorganisms based on risk assessment. Microorganisms are categorized into 4 risk groups based on their pathogenicity or their ability to cause infection to the person handling the organism, their mode of transmission from one person to another and to the community, which is based on the stability of the organism in the environment and the concentration of material, if there are any treatment options available, and if there are any preventive measures like vaccines or chemoprophylaxis available. Risk Group 1 organisms have low or no risk to the individual handling it and the community. They are unlikely to cause human or animal disease. Examples are Lactobacillus species and non-pathogenic strain of E. coli. Risk Group 2 organisms have a moderate risk to the individual and a low risk of transmission to the community. They can infect the laboratory workers, the community, livestock, or the environment. However, effective treatment and preventive measures are readily available. Therefore, the risk of spread of infection is limited. Examples are Staphylococcus aureus and pathogenic E. coli. Risk Group 3 organisms have a high risk to the individual and a low risk to the community. However, they can cause serious human or animal disease. Effective treatment and preventive measures are available. Examples: Mycobacterium tuberculosis, Burkholderia pseudomallei, and Salmonella typhi. Risk Group 4 organisms have high individual and community risk, and they can cause serious human or animal disease, which may be readily transmitted directly or indirectly, and effective treatment or preventive measures are not usually available. Example: Ebola and Marburg viruses. Biosafety levels. They are sometimes referred to as containment levels. They are a set of biocontainment precautions required to isolate dangerous biological agents in an enclosed laboratory facility. Categorization. There are 4 biosafety levels, where the numbers represent increasing virulence of the microbes being handled. So, biosafety level 1 deals with low-risk microbes, and biosafety level 4 handles microbes with the highest risk. The levels of containment determined based on the risk of infectivity, severity of disease, transmissibility, and the nature of the work conducted. The origin of microbe and route of exposure are also important. Each level has specific controls for containment of the microbes and biological agents based on laboratory practices, safety equipment, and facility construction. Biosafety Level 1. The microbes here are not known to cause disease in healthy adults and present minimal potential hazard to laboratorians and the environment. An example of a microbe that is typically worked with at a biosafety level 1 is a non-pathogenic strain of E. coli. The laboratory practices. Standard microbiological practices are followed. The work can be performed on an open bench or table. The safety equipment required are personal protective equipment like lab coats, gloves, and eye protection, which are worn as needed. The facility construction. A sink must be available for hand washing, and the laboratory should have doors to separate the working space from the rest of the facility. The image shows the work being done on the open bench top following standard microbiological practices, and the personnel is wearing a lab coat and gloves based on the need of the work being done. Biosafety Level 2. The microbes here pose moderate hazard to the laboratorians and the environment, and are typically indigenous and associated with diseases of varying severity. An example of a microbe that is typically worked with at a biosafety level 2 laboratory is Staphylococcus aureus. This is the type of biosafety level followed in most clinical diagnostic laboratories. Laboratory practices. Access to laboratory is restricted when work is being conducted. Safety equipment. Appropriate PPE is worn, including lab coats and gloves. Eye protection and face shields may also be worn as needed. All procedures that can cause infection from aerosols or splashes are performed within a biosafety cabinet of Class 2A. An autoclave or an alternative method of decontamination is available for proper disposals. Facility construction. The laboratory should have self-closing doors. A sink and an eye wash are readily available. This image shows the work being done in a biosafety cabinet, probably Class 2A, with appropriate personal protective equipment like lab coat and gloves being worn. Biosafety Level 3. The microbes here can be either indigenous or exotic, and they can cause serious or potentially lethal disease through respiratory transmission. Respiratory transmission is the inhalation route of exposure. One example of a microbe that is typically worked with in a biosafety level 3 laboratory is Mycobacterium tuberculosis. Laboratory practices. The personnel working in the laboratory are under medical surveillance and might receive immunizations. Access to the laboratory is restricted and controlled at all times. Safety equipment. Appropriate PPE like solid front gowns must be worn and respirators might be required. All work with microbes must be performed within an appropriate biosafety cabinet of Class 2B. Facility construction. A hands-free sink and an eye wash station must be available near the exit. The exhaust air must not be recirculated within the lab and must be released to the outside after passing through a HEPA filter. The laboratory must have sustained unidirectional airflow by drawing air into the laboratory from the clean areas towards potentially contaminated areas by negative pressure. The entrance to the laboratory is through two sets of self-closing and locking doors. This image shows the work being done in a biosafety cabinet, probably class 2B, with appropriate PPE like a solid front gown, gloves, respirator, and a face shield being worn. Biosafety Level 4. The microbes in a biosafety level 4 laboratory are dangerous and exotic, posing a high risk of aerosol transmitted infections. Infections caused by these microbes are frequently fatal and without treatment or vaccines. Two examples of microbes worked within a biosafety level 4 laboratory include Ebola and Marburg viruses. Laboratory practices. Change of clothing before entering the laboratory and shower upon exiting the laboratory. All materials are to be decontaminated before exiting the laboratory. Safety equipment. All work with the microbe must be performed either within an appropriate Class 3 biosafety cabinet or by wearing a full body air supplied positive pressure suit. Facility construction. The laboratory is in a separate building or in an isolated or restricted zone of the building. The laboratory has dedicated supply and exhaust air as well as vacuum lines and decontamination systems. This image shows the work being done in a biosafety cabinet but not class 3. However, the personnel are wearing a full body air supplied positive pressure suit while working in the laboratory. Please note that no part of the body is exposed to the laboratory environment. Let us quickly revise through the different biosafety levels and their requirements. Biosafety level 1 requires open bench work, PPE as per need, and good microbiological techniques. Biosafety level 2 requires access limited to laboratory personnel, PPE like lab coat and gloves, specimen handling in a class 2A biosafety cabinet, autoclave for sterilization of waste, and material for disposal stored and handled carefully. Biosafety level 3 requires specimen handling strictly in class 2B biosafety cabinet, situation of the laboratory away from general circulation with a separate biohazard sign at entry, airflow monitored and exhausted via HEPA filter, and should have its own equipment. Biosafety level